Sir. Good afternoon. We are going to start. Yeah, is it audible clearly? Purnasthi, can you hear me?
Sir?
Yes, sir.
Yes.
Sir, we
Yes,
might have project review now, so once I complete, I'll join the class.
No, it has been completed, project review.
No, sir,
2
only
o'clock we have
starting
started
for
today
3
project.
groups they did, sir. Then they had some lecture or something, so they might take now, sir.
All right, what about others, Jay Surya and all that?
Sir?
Others, Jay Surya and others, other students?
I don't know, sir.
Aishwarya.
Like me, me, Nitish and Darshan will join later, sir, after the review.
Okay, join first.
Okay, sir.
So, yeah. So this is the last lecture, last session. This is the 5th lecture actually. This class is being recorded from the All India Council Technical Education. It's an initiative given by AICT. It's under the Ministry of HRD, Government of India. So Aicte Prerana classes for motivating and for preparing the SCSC students for the higher education. So this is the learning platform, and CMR Institute of Technology has taken an initiative for taking these classes. Myself, Professor Narendra from Civil Department. So my basic background from the environmental engineering, BTech and BTech and MTech in environmental engineering, and then PhD in environmental engineering. So I have 10 years of experience in this industrial as well as the academic field of this civil engineering. So, so today we'll be talking about, we have till now completed water supply and treatment engineering and the wastewater engineering part, design and planning of sewer network we have completed. And before that, in water supply and treatment engineering, all the unit operations, including the distribution network, started from aeration, plain sedimentation, pre-chlorination, then plain sedimentation, and sedimentation followed by coagulation, design a primary sedimentation tank, and then filtration units, slow sand filtration, rapid sand filtration. We have done couple of numericals from the gate point of view. Then we have moved for the filtration. After filtration, we have moved for the disinfection units, right? Chlorination, post chlorination, various forms of chlorination we have studied. We have done some couple of numerical how the reactions will take place, and, and how we will supply a chlorine. How what are the doses of the chlorine that we have to decided. And then we have done studied about the ozonation also. After that, we have studied in the last class about the distribution network, various approaches for the distribution network design and analysis, Hardy-Cross methods. We have Hardy-Cross method we have explained last time, and we have gone through the detailed 2 to 3 numerical also how to approach that. So now the water supply and treatment engineering, we have completed previous 2 classes, and then third class, the fourth class was about the wastewater engineering, where the design and planning of sewer network we have studied, including the wastewater characteristics, physical, chemical, and biological characteristics also we have studied. We have done some numerical on that. Now this is the last session, which will be totally we are focusing on for the natural disposal methods, self-purification methods, as well as the unit operation of sewage treatment plant. So the wastewater engineering, this is the last unit operation part, where all the unit operation, primary, secondary, will be completed, including some numericals. So these part we have discussed last time. Tuition systems limited. For the main part that we want to discuss today. Is all about 57 factors. That will talk later. Therefore, that will go for this portion. We have studied about the sewer cleaning part and the maintenance part, right? How to identify the leakages and all that. We have done about the wastewater characteristics also. We have studied. So natural purification. Then I will go typically. As you know, it's a natural purification methods of wastewater disposal. Either you can treat for the primary treatment, you can provide it, and then you can discharge into the river and lake and freshwater body sources. And last time we have discussed till then, these are dilution, dispersion, sedimentation, oxidation, reduction, and temperature and sunlight, depending factors, and how the dilution will take place. So it's a natural process. If we have large flowing bodies, fresh water body surface source, like rivers and lakes, and you can discharge the sewage water. Maybe partial treatment you can provide it, and then you can discharge it. And because of the natural process of purification, the oxidation reduction, because the dissolved oxygen is there in that, it helps in various oxidation processes, and organic matter will decompose finally by its natural methods. There's a diffusion currents, and the water is mixing thoroughly. The dissolved oxygen is mixing thoroughly, and the various phases water will be treated naturally. So that was the equation for the concentration equalization that we have studied. Cs into Qs plus Cr into Ks. Suppose we have a wastewater stream where the sewage water is discharged into the freshwater body river. So like this, you can take the concentration of the sewage and then flow rate of the sewage, and then Cr is the concentration of the river and Qr is the flow rate of the river. And this conjured equation will be followed for getting the mix water concentration. If you want to find out, you can get it. Dispersion due to currents. Sedimentation, these are the following factors, 7 factors, as I told you, depending factors. Oxidation, reduction, these are the process will take place in sequence. And temperature and sunlight play a very important role. As I told you, high temperature solubility will be low, and the low dissolved oxygen will be there in that. And sunlight and temperature play a very important role for the aerobic decomposition of organic matter. So as if you see the photosynthesis process of plants, also sunlight and temperature play an important role. In the same way, the like the microorganisms will absorb CO2 and give out the oxygen. The self purification process will be faster. This is zone of pollution in the stream. So half an hour I will talk about the self irrigation methods. Then I will move for the sewage treatment plant. Okay. So this is the well-known curve. This is the physical indications. DO sector we call it, usually. This is the DO sec curve. This is the saturated level of dissolved oxygen, where the saturated a sufficient amount of dissolved oxygen is present in a fresh water body. At this moment, we are going to discharge the sewage water. Till that, there is no problem. Once you discharge this untreated, partially treated sewage water there, so organic matter present in a wastewater, a lot of impurities present in a wastewater, organic impurities. The bacteria will start consuming this oxygen available in a water, in a fresh water body source. And then the bacteria and microbes start consuming these organic matter present in the water, and then aerobic decomposition will take place. Of course, the dissolved oxygen component percentage will reduce, and it will reach it to its the minimum level of dissolved oxygen, or sometimes here septic zones or zone of active decomposition. After that, because of the mixing in circulation currents, again this reaeration will take place, and dissolved oxygen from the atmosphere will start dissolving, and then it's a recovery zone. Again, the amount of dissolved oxygen start increasing in the recovery zone. And the color identification is given here. So this is the clear water zone, no bottom sludge. The floating solids bottom sludge color and turbidity will be visible here. Here, this is the septic zones where the dissolved oxygen will be very less or sometimes negligible. No dissolved oxygen present in this. Here, this is the anaerobic digestion takes place actually. The color of the water will be grayish and darker. The methane, hydrogen disulfide, C gas, N2 gas, inert gas will be present here. The color will be black foam at top. Sludge will be generated at the bottom. And then recovery zone, the turbid color will become fade actually here, and the turbid with bottom sludge will be generated. And finally, the zone of clear water, where again the dissolved oxygen will reach to its saturated level. So this is the saturated DO curve, the DO sec curve. In this clear water zone, finally the water will be treated naturally by doing anything. Okay. So these are the whole process what I have explained, and that way step by step it will go. So this is saturated DO level, and this is dissolved oxygen curve where all the joints will be taking place. Yeah. Now one thing is the deoxygenation rate as well as the reoxygenation rate. That is important while you are going for the street valve equation. Then the oxygenation rate as well as the reoxygenation rate you have to required. You have required for it. This is all the process. Deoxygenation rate as well as both the oxygenation as well as reoxygenation, both processes takes place simultaneously actually. So this is the same old curve, old DO sec curve. This is the critical point where the critical DO, minimum component, minimum DO will be present. And you see this diagram, time of flow we have taken on x-axis, and DO concentration we have taken in percentage on y-axis. Now if you see that, because this is the zone of degradation where the oxygen dissolved oxygen start consuming by the bacteria, and the percentage will decrease simultaneously. So decreases happen this zone. So this zone is called as a deoxygenation curve rate. So will the by the exponential analysis, we can you have simple derivation. You can get the value of deoxygenation curve, deoxygenation rate. Now another is simultaneously the deoxygenation rate, deoxygenation curve also will be followed. Both the process will be taking place simultaneously, and because reaeration and mixing and because water is in a flowing motion, so the currents are happening, and then again reaeration will be taking place. So again atmospheric oxygen will dissolve. So reaeration as well as the deoxygenation rate both will takes place simultaneously, and finally the saturation level will come there, and the both will be balanced. Supposedly there is a second, there is a third, and this curve will give the combined reactions second and third both. Yeah. So at the same time, oxygen gets added into the stream through various processes such as photosynthesis rains. The curve representing oxygen gaining process is known as reoxygenation curve, and it depends on the organic pollutant present in temperature. The variation or depletion of the DO is represented graphically by deoxygenation curve. Okay. So pollution load is discharged into the stream. The DO gets reducing. This process is known as deoxygenation. So we have to get the value of DO deficit. DO deficit is nothing but the saturated DO minus actual DO, the difference between the saturated DO and actual DO. So simply DO saturated minus DO act, you will get a DO deficit. Okay, the amount of DO deficit can be obtained by graphically adding both the curves, and the resulting curve is known as the DO sag curve. So based on this, a Street-Phelps equation has been derived. It's analysis of DO sag curve. This is called a Street-Phelps equation. So rate of increase of DO deficit is equal to rate of deoxygenation minus rate of reaeration. As I told you, both the processes are taking place finally simultaneously. So you have to balance the reaction. Suppose in the energy reaction we used to do this, Qn is equal to Q out plus how much losses. The same way you have to balance the equation. So how much rate of increase of DO deficit is happening is equal to rate of deoxygenation rate minus rate of reaeration rate. The mass balance equation written out in the words, you can write it: accumulation is equal to how much in minus how much out plus how much in, what is the reactions and what is the difference we have it. So because we are looking at the element by itself, there is no flow of water into or out of it. So the mass balance on the oxygen becomes like V into dc by dt is equal to O in minus O out plus rate of oxygen removed by degradation volume plus rate of oxygenation the atmosphere with B. There here we have rate of one and another one is rate of deoxygenation. Oxygen removed by biodegradants, you can write it in D is subscript oxidation rate is equal to rate of decay. It will be exponential. You can see the graph. It is exponentially decreasing. So you can exponentially, it is decreasing actually minus. So we have written as a minus here. So minus K into DL, you can write it. L is the ultimate BOD of the organics remaining in the water at any time t. Kd is the first order degradation rate constant. Kd is related to, but it is not numerically the same as the KBOD. That is not important. Yeah. So this derivation we have done in conventional classes also. So dc by dt for the reoxygenation rate also you have to go in reoxygenation rate. What is happening? The oxygen dissolved oxygen amount is increasing. So plus sign we have to take it. So K R in subscript, K R represent reoxygenation. So Kr multiply with Cs minus C. C is the dissolved oxygen concentration. Cs is the dissolved oxygen concentration at saturation level. So this is predicted from the Henry law, Henry laws of gases. So Kr is similar to the rate constant, reaeration rate constant, similar to the Henry gas constant. This value will be related to the characteristics of the streams, and this is basic differential equation that must be solved. So you can solve it. Both the rates you have to combine it. So basic equation will be volume dc by dt is equal to dc by deoxygenation rate plus reoxygenation of both. You will get the complete value. Dc we cancel. Then finally you will put the value of dc by dt, that is minus kd into L you have determined, and then here you got it, that is kr into cs minus c. So if you go for the addition for both. Mathematically, it is convenient to express everything in terms of the derivative of d. So what is du deficit? Saturated du minus actual du. So Cs minus C. So Cs minus C you can represent by du. D, we can say du deficit, you can write it. So finally, you can solve in that manner. So d, so if you go the first order differentiation with respect to t for this equation, so dt by dt is equal to keep this constant as 0 minus dc by dt. Then finally you can get this answer kd kr into cs minus c. If you go to over one order differentiation, and if you put the following value, so you will get this equation. And then finally we solve further. Finally, we have written an exponential form. If you integrate this whole number, you will get an exponential form. This minus kr into d. Then kr into d you can take in left hand side. So it will become a first order differential equation. So the arrangement is called as a standard form of first order differential equation. You can solve it by using integration factor and all that. So this will be in that form. So integration factor for it, exponential of the integration of kr into dt, it will be e to the power krt finally. So this is the integration factor, and you have to multiply on both the sides this integration factor in this equation. So dt by dt into e to the power krt plus kr into d to the power, whole equation will become in that form. You can write it in the standard form because it's a whole is a derivative of capital D into exponential of the krt. If you do the derivative first order, first and second u and v formula, derivative with respect to u and v formula, first and second. Okay. So if you do this, it will come in this form. So this is finally a derivative of this, and then kd will remain constant, L naught remain will constant, e to the power minus kd, k you can write it in that way. E to the power t you can take a constant, so kr minus kd into t. So finally you will get it. So if you separate the variables, if you do it first time integration here, if you do the separation of the variables method, so separated here, derivatives of d into e to the power krt, integration, derivative of whole number. So you will get the final this. Derivative of e to the power ekt is equal to d is equal to kd into L naught divided by kr minus kd into e to the power kr minus kd into t plus c. And c is the coefficient of integration that we have to solve by using a boundary value condition. What boundary value conditions you can apply? At t is equal to 0, d will become d naught. At t time is equal to 0, d will become a d naught. So if you put in this equation, t is equal to 0 if you put it here, and then if you put a d is equal to d naught, replace d by d naught. So d naught you have replaced it, you get it. You solve this further equation, finally the c value you will get. So finally, if the c value if you replace here, you will get the whole iteration here like this. So you are going to rearrange it here. If you rearrange it, the d value you will get it finally, first order derivative d. So finally you will get kd into L naught divided by kr minus kd into exponential of the minus kdt, the whole equation. Finally, after grouping the like terms in integrated equation will become like this form. And this is the standard equation for called as a street self equation for D. So for this graph, you will get this fraction of dissolved oxygen amount at the particular time interval. So finally, these notation I have already explained everything. So when we use a DO-sec equation to find the concentration at any point downstream of a waste discharge, as long as we know the travel time to that point, which is easy to calculate if the stream velocity is known. So these are D naught is the deficit at t is equal to 0, and L naught and DO naught are the values in the stream after any external waste streams have been mixed in. So like this for it. So finally, you will get using this DO sector, you will get this value. If you want to get the value of C, that's DO deficit, then CS minus D, or D you already know that. If you put this D value here, then again you will solve it in make it in general form, and then you will get the final this formula. The actual DO component, the actual graph will vary like this based on the experimental reports. So DO will be in y-axis, distance traveled in kilometer on x-axis, and you will get various points. Now this is your final value for D. You got it. If you differentiate with respect to T and equate to 0, to find the critical time and critical deficit, differentiate the street valve equation and set it equal to 0. So critical value you will get it, at TC value you will get it here. So TC will be the critical time taken for reaching the critical DO component. So ST is equal to TC. You will get this equation 1 upon KR minus KD into ST is equal to TC minus TR.
Sir, unmute your mic, sir. Sir,
Sir, we can't hear you, sir.
So we can't hear you.
sir,
Yeah, yeah. Now is it audible? Yeah. It is this one, sir. Many other. Yeah, where we were? Here. Okay. So here you see that. So this is
Yes,
your
sir.
standard equation for the steep LP, the dissolution component at a particular time. You will get it. And then this was the critical DO that we have derived just now. So critical point where the stream conditions are at their worst. So L naught is used to put as L naught here. This is the standard we have put it. Ultimate VOD after mixing. So these equations you have to remind it. You have to remember it while you are solving the equations. Yeah, numerical if you are doing it. Okay. So lowest value of DO you can get it C saturated minus DC as I told you. If you get this value DC, you will put it here. You will get it. Yeah. This is one equation for DC, another equation for this one, this equation that we have derived. No, this equation also. Generally, they will focus in this equation. If the numerical is larger, then they will go for this one. Okay, so you don't worry. So KD and KT will be given. KD and KR will be given in the exam. L naught will be obviously given. And what is unknown here? DT you can get. So like the same way, if you see there, L naught will be given. This is the LA L naught. It is equal. So the standard. That's why we have put it. It's L naught actually. Yeah? So all the things will be given. You can get both the values TC and DC. If you have a DC value, then lowest value of DO also you can get. Okay. These are some certain numericals on this that we have done it. So distance traveled on x-axis and DO sec curve will be on y-axis. How much dissolution is required? So time you will get this distance also you have to take it sometimes. So distance you can generally take for the linear equations. Uh, Distance divided by time, you will get the velocity. In the same way, you will get EC critical time multiply with velocity of flow. You will get a distance traveled by the pollutant in the stream. So the deoxygenation constant K varies with temperature. If temperature is also given, then this formula you have to use it. KT, T is in a subscript here, not a multiplication, is equal to K20. This Q20 is also in subscript. Multiply with Q to the power T minus 20 degree. So if they are asking about the temperature also in the question, if it is given, then this equation you have to use it sometime. So this theta value, this is theta actually, not Q. The theta value may be taken as 1.056 for each range for 20 to 30 degrees Celsius, and as 1.135 for temperature range for 4 degree to 20 degrees Celsius. What is the time? Yeah, the self-purification constant, you will get the ratio of yeah. So what is the sleek and sludge blank? What is going to have a specific gravity is higher for this ocean water, temperature lower than the sewage stream. What will happen? What is the
Sir, you're not audible, sir. Sir, you're not audible, sir. Sir, are you talking something? You're not audible, sir. No, sir, it's not audible.
Can you hear me?
Yes, sir, now I can hear you.
My God. This disturbance, no. This net.
But increase the volume, sir, it's so low.
Okay. Now it's fine. Is it clear?
Yes, sir.
Alright. Let's see how much we can complete in then one more class we have to take for 1 hour. Then. So that was about the disposal by landfill. We've almost reached 40 minutes, 30, 40 minutes. What's the time? 5:10. Okay. So this is the disposal by land treatment, last one, and then either you have to treat the waste or partially you have to treat the waste, and then you can send it to the surface land itself. For the it can be used as a sewage farming or as a fertilizer. Also, we can use it. There are various advantages for it. And there are some conditions for disposing of this sewage. The sewage should not be very toxic. It should not have any toxic chemicals with it. And there are some standards limit for the sewage disposal into the land. So you have to go for the water quality analysis first, and based on this, you have to check the parameters. If you are if the all the BUD, COD, your pH level, your total suspended solids, and even the inorganic metals all are coming under the limit, then you can dispose it of. Okay. So land treatment. Some part of the wastewater evaporates while the other part percolates in the ground, leaving behind the suspended solids, which are partly acted upon by the bacteria and partly oxidized by the exposure to the atmosphere because of the action of the air, heat, and light. So there's a self-purification will takes place once you put the waste on the open end, wastewater in the open end. Of course, with due to the time, the natural purification will take place, but it's a long process. And another thing is the bad smell and odor is also a problem. So it is not safe. But if we are not able to treat the sewage water on that extent, we don't so have a sewage treatment plant in a small town and all that, then you can do it. But we should have open land without any disturbance, and you can use the sewage part for sewage farming also. That is also a good thing. So there are the three principles based on the land treatment of waste treatment or the land treatment of wastewater. One is the broad irrigation of sewage farming. Second is rapid infiltration. Third one is the overland runoff. The first process depends upon moving or percolating the water downwards to the soil, and thus are limited by infiltration percolating capacity of the land. So if wastewater doesn't have any significant impurities which is harmful for the water, you can discharge it. So of course the some amount of water will infiltrate and percolate, some impurities will infiltrate and percolate. If it is not too harmful, then you can discharge it. So we have to check the infiltration capacity and percolation capacity of the land or soil also. So percolating capacity is a function of the soil characteristics. Infiltration depend upon the degree of the clogging at the soil surface, that we have to check it. First is the rapid infiltration that we have told it. So there's a slow rate systems. It's a predominant form of the land treatment for the municipal and industrial wastewater. As technology incorporates wastewater reuse, crop utilization of nutrients, and wastewater disposal. And we have various methods for the irrigation, like a sprinkler method, subsurface methods, furrow methods of irrigation, drip irrigation also. So you can use it as a for the irrigating of your crops, like a sewage farming. Okay, and yeah, this is a rapid infiltration method. Water will be percolated, infiltrated into the soil. Some portion, and some water can be used for the irrigation purpose. These are the method application for the wastewater. Like we have told three methods: surface irrigation and subsurface irrigation methods. In surface irrigation, we have tubation method and flooding methods, furrow methods. And then we have a sprinkler irrigation method also. So process by which purification of the sewage takes place in first two methods: mechanical straining and filtration of the organic matter present in the sewage. So complex compounds in the sewage are thus converted into the harmless mineral salts, which are serve as a valuable fertilizers. So two uses: you can use it for the irrigation this wastewater as well as the natural fertilizer you will get it. This is a sewage farming. It is very good concept, but if the excess nutrients are available, nitrogen, phosphorus, and potassium, then it creates a problem. So the partially treatment is required, primary and second treatment is required, then you can discharge it without any harm. So it's a very good concept for the organic farming. This wastewater can be used for the irrigation purpose. So without polluting the soil, good quality sanitary manners, open water courses, there are some constraints that you have to maintain. Hygienic environment you have to maintain in the surrounding. Contamination of the crop raised on the sewage farming, you have to check it, contamination and all that. And the soil quality should not degrade with respect to time. These are the effluent standards that you have to maintain for the various chemicals, physical, chemical, biological chemicals characteristics you have to check, and then into the land, into the inland surface waters, on land for irrigation, and into the marine coastal areas discharge. These are the standards that we have to follow before discharging the wastewater into the land. Condition favorable for the land treatments. There are the various conditions that we have to for the climate conditions as to be considered. Land treatment good, subsoil water table is favored when rainfall is low and there is an acute demand for the irrigation water. So in arid regions, most of the desert regions, this method is quite useful, sewage farming method, and we can go for the sprinkler and drip irrigation there because water shortage is there. And then when river run dry or have a very small flow during summers, and discharging sewage into them is also one of the good solution. If the river is dying day by day, if there is no water in that, then also you can directly discharge into the river. But make sure that the river is flowing. If this flowing stream should be there, it should not be a stagnant water body source. Another is a broad irrigation. It is similar to the sewage farming, to the purpose of the tool are different. In the sewage farming, the prime consideration is the successful growing of the crops, while in the broad irrigation, effluent irrigation, the prime concern is the successful disposal of the sewage. Yeah, aerobic void soils, raw or settled, both sewage can be used. This is the sewage sickness. If with the continuous application of the sewage on the land, the pores of the soil gets clogged and preventing oxidation and causing noxious smell. The land is unable to take any further load of the sewage. This phenomenon is called as the soil sewage sickness. So that you have to take care. The prevention, pre-treatment of the sewage is required if you want to protect it, your land from the sewage sickness. Provision of extra land, under drainage of the soil, proper choice of the land, and rotation of the crops is also help in this. So the fertility can be maintained. The shallow depth application also. Okay. These are all about the land treatment of sewage disposal methods. So I'll be moving for the treatment part. Okay. I'm going a little bit faster. You'll be having PPT. I will circulate all the PPT to you. Just go through there and then study the details. The numerical parts also I have circulated some of the part, and the unit wise, I mean not topic wise, I will circulate the questions. We just solve it. Okay. So I'm moving for the sewage part now, sewage treatment part. Design and planning phase we have completed in 2 lectures. Now the sewage part, treatment part is very important. Okay. So these are the things that we will go. Flow diagram of municipal wastewater treatment, unit operations, like the preliminary treatment process, like steam, get chamber, skimming, and equalization tank. Then we'll go for the primary treatment, like primary clarifier, and then we'll go for the your secondary treatment processes, like secondary clarifier, addition tank, activated sludge process, trickling filters. We'll study all those things in detail. And we have two types of process: suspended growth culture, as well as the we can say the attached growth culture of the bacteria. So in a like aerobic decomposition and anaerobic decomposition, two types of process will be taking place. The bacteria will attach with the with the uh, with the food, or it will be in a suspension form in a wastewater. So like this will be for it. This is a sewage treatment plant, typical sewage treatment plant diagram. raw sewage water is coming. It will be passing through the peeling bead process like coarse skin and fine skins. Then water will pass through the grit where the all the clay, sand, um, and glass metals, glass fragment, and all those things will be separated out. It will be automatically cleaned by the various mechanical machineries, and the screening is required for removing the debris and physical impurities, leaves, and all that. So it can be removed. So after the grid chamber, water will be sent. You can send the water for the skimming tank, oil and skimming tank, where the oily and greasy component of wastewater can be removed. So because the sewage water is having a lot of oil and greasy component, so that can be removed. It creates a problem for the further treatment of the processes, so we have to remove it. After that, water will be sent for the primary clarifier, the primary sedimentation tank. Sometimes we can say as a primary settling tank, where the physical sedimentation as well as the chemical precipitation process will be taking place. There are the two processes here: plain sedimentation and sedimentation followed by coagulation. So if you are adding a coagulation, the process will be faster. There are the various hydraulic parameters that you have to check it here, like detention time, surface loading rate, surface overflow rate, right? And horizontal velocity of flow also you have to check it. There are the various steps of sedimentation tank: horizontal flow, vertical flow type. We have a circular type of circular type of sedimentation tank, rectangle type of sedimentation tank. So these are the various designs that we will study. The reason for providing a primary sedimentation tank to remove the suspended solids present in the water and all the undissolved impurities. Mainly the suspended solid will be removed. Some percentage of TDS also, total dissolved solids also will be removed here in this primary clarifier process. And then water will be sending for the, suppose this is the activated sludge process based sewage treatment plant. So water will be sent for the aeration tank where the sufficient amount of aeration is dissolved in a water by using a diffused aerator or mechanical aerators. And it should be mixed also. There are some agitators and agitator and mixing devices are also incorporated with this. So sufficient amount of oxygen will be dissolved here. As I told you, aeration, atmospheric oxygen, if you are dissolving in the water, it helps in removing the bad odor and taste from the water, and also it will remove the hydrogen disulfide and nitrogen disulfide, other gases, the inert gases, and it helps to iron and manganese also, to remove the iron and manganese component with some fraction. Aeration help in biological treatment a lot. The aerobic decomposition process will be taking place here. Then after that, water will be sending for the secondary clarifier. These whole process, aeration tank as well as the secondary clarifier, will be called as the activated sludge process, where the written activated sludge also will be coming, will be taking some bacteria, and then sludge treatment also will be followed with this. So activated sludge process will be very effective. It's a suspended growth process of bacteria. Suspended growth culture will happen here, and its addition decomposition process. So we'll go one by one about all the processes, and then the secondary clarifier. The design will be quite similar from the as the primary clarifier is concerned. So all the detention time, velocity, horizontal velocity, and then over surface overflow rate, all those things you have to divide here also. Then there is a sludge thickening, a sludge treatment process where the sludge thickening, sludge drying operations have to be carried out. You need to get the stabilized sludge, which is biologically and chemically inactive, and this sludge treatment process will be followed by the sludge drying bed, sludge thickening bed, right? There's dewatering of the sludge operations. There are a lot of operations for the sludge stabilization process. You can generate the biogas also through this. Biogas can be used for your um, kitchen purpose, and for the cooking uses, as well as the electricity also you can generate it as a bioelectricity by using the biogenerators. And the other is the natural compost. It is a very good natural compost. You will get it. This stabilized sludge is a very good source for the natural fertilizer. You can use it. Then finally treated water will be sending for the disinfecting purpose. After disinfecting, you can take it as a send it for the discharge in a river water body or surface water body. This is the whole process which will be moved. Here are the lot of digesters. Digesters play a very important role in sewage because mostly we are dealing with the organic matter of treatment, organic matter decomposition. So the digester play a very important role. So There are the two types of process, and if I'm talking about the biological treatment point of view, that I will talk later. Okay. These are the unit operations, a process, a combination of operations and process that can reduce the objectionable properties of water and rendered into the less dense is called as a operational unit operations. So wastewater treatment is a combination of three process, unit operation, physical, chemical, and biological treatment. Sometimes in the combination of physical, chemical, and physico-biological treatment also followed. So method of treatment involves the application of physical force or predominant alcohol as a physical unit operations. The method of treatment involves the chemical or biological activities are followed as known as biological chemical unit operations. So, unit operations approach in water and wastewater treatment has the following advantage: gives better understanding of the process and capability of these process in attending the objective. We want a clear water. We want the water should be free from the objectionable substances, so it should not harm the air and soil and water. So we want a clear water which can be easily disposed of into the river water bodies with the safe disposal methods. We don't want any toxic component in that. So help in developing mathematical and physical model of treatment mechanism and consequent design of the treatment plants. So once you understand the water quality of a particular sewage water, it will be easy to design what unit operations are required and what is not required. So in the both the way it will help it. Yeah. So these are the physical unit operations: screening, comminution, and flow equalization, mixing, flocculation, sedimentation, flotation, filtration, and micro screening. Various objective for it. Like screening is required for removing coarse and settleable solids from by surface straining. Flow equalization is required to equalize the flow and mass balancing. Your pH level you have to equalize it. If concentration you have to equalize it. Sometimes water is coming from various streams, so maybe the concentration can be different. The pH level also can be different. So it will be easy to treat for the further sewage load while you are going for the biological treatment if the concentration is equalized. Mixing is required, a lot of agitators and flow mixing is required. Sometimes you have to add some coagulant also, then mixing is also required, and flash mixing chamber you have to provide it, okay, for it. So for mixing of chemical and gases with the wastewater and maintaining solids in suspension also. Like in the suspension growth process, if I'm talking about the uh, activated sludge process, which is the bacteria will be in a suspension form, where you need to agitate the wastewater continuously, so the bacteria can be in suspension form. So their agitators and these mixing devices are required. In sedimentation, removing of settleable solids and thickening of sludge is required. Flotation, removing of finely divided suspended solids. Okay. So these are the unit operations. Filtration is required for removing a finely suspended solid, fine residual suspended solid, which cannot be removed by the sedimentation tank. Then it helps in biological treatment also, in chemical treatment also somewhat. It helps to reduce the bacterial growth also. Like it helps in organic matter decomposition also somewhat. These filtration. And here some in the sewage treatment plant, we generally use a trickling filters and biological contractors. In most of the cases, trickling filters are used. These biological filters in which it helps to reduce the biological load also in the sewage water. It's an aerobic decomposition process. We used sprayers. You can see the blowers and aerators for it. There are some micro screening process also that is for removing the algae from the stabilization point. These are chemical unit operations. Chemical precipitation is required to remove the phosphorus and elements of suspended solids removal in primary sedimentation, gas transfer, addition and removal of gases, absorption process, surface absorption it is, surface absorption and diffusion processes. Then disinfection is required, generally chlorination and ozonation we have to follow with this. And dechlorination is also the chemical process, excess chlorine removing processes. If the chlorine is dissolved in excess amount that you have to remove it, that is called as dechlorination. If it crosses the soil, it is in a superchlorination manner, then superchlorination always followed with the dechlorination. Okay. These are the biological unit operations. Biological unit operations are those in which the removal of contaminant are brought about by using the biological activities. In biological treatment of wastewater, the objects are to be coagulate and remove the non-circulating colloidal solids and to stabilize the organic matter. The wastewater is generally from the three sources: domestic wastewater, agriculture, written wastewater, as well as industrial wastewater. For the domestic wastewater, the objective is to remove the various nutrients, especially nitrogen, phosphorus, which are otherwise capable of stimulating growth of aquatic plants and removing all bacteria also. The biological processes are classified by the oxygen dependency of the primary microorganism responsible of wastewater. There are the two types of process here: aerobic process as well as the anaerobic process. The regular classes also we have discussed these things if you have attended. So we will be moving further in the detail also, because in GATE classes we have a time limitations. In your regular classes, I will discuss one by one in detail about all those things. So here is the challenge: we have to finish in 2 hours the whole subject. It is not possible, but we will try. Okay. So I will little bit faster in a slow way. We will explain each and everything in your regular classes. Okay. So Arabic process. There are the two types of biological processes that will be taking place. One is the Arabic process and anaerobic process. Another one is the facultative process. Arabic and anaerobic both are combined in this. So it's a bacterial based actually. The microbes and microorganisms play a very important role for decomposing of organic matter. So some of the bacteria can survive in Arabic conditions. Some of the bacteria can survive in Arabic conditions. Some of the bacteria can survive in both the conditions, Arabic and anaerobic conditions, right? Some of the bacteria can survive on a surface certain temperature range. So we call it as Arabic bacteria and anaerobic bacteria. If I'm talking on the temperature base, then we have a thermophilic bacteria, mesophilic bacteria, like this. So in aerobic process, biological treatment process that occur in the presence of the dissolved oxygen, the bacteria that can survive in the presence of the dissolved oxygen are known as obligate aerobes, aerobic bacteria. The aerobic process includes the activated sludge process, aerobic stabilization pond, aerated lagoons, and trickling filter. All are aerobic processes. And another one is the anaerobic process. The anaerobic waste treatment involves the decomposition of the organic matter and or the inorganic matter in the absence of the molecular oxygen. Anaerobic process consists of the following: anaerobic sludge digestion, anaerobic contact processes, anaerobic filters, and anaerobic lagoons and ponds. One is third process is the aerobic anaerobic process, combination of both further process. So are those in which the stabilization of waste is brought about by a combination of aerobic, anaerobic, and facultative bacteria. We'll move for the secondary treatment typically. So as I told you, it is required to remove the soluble and colloidal organic matters present in our water in primary treatment. In the case of domestic wastewater, the objectives of biological treatment is to stabilize the organic matter finally. We want organic matter should be completely stabilized and should be chemically and biologically inactive. So to remove the nutrients as nitrogen, phosphorus also is the main objective for the secondary treatment. Now, the secondary treatment process may be further classified in three terms. One is the attached film growth process, another one is the suspended growth process, and third one is the combined growth process. So this is very important. See, the trickling filters comes under the attached growth process, attached film growth process. The activated soil process will come under suspended growth process, a suspended culture growth process, where the bacteria will be in suspension form, or bacteria will attach with the biomass. So attached growth process utilize sodium solid medium like rocks, slags, or plastic materials, upon which the bacterial solids are accumulated, attached with that. They convert organic matter into the gases in cell tissues. Such surface growth process include the intermittent sand filters, trickling filters, rotating biological contractors, packed bed reactors, anaerobic lagoons, and fixed film denitrification. These are the all process comes under the attached growth process. Under the suspended growth process, maintain adequate biological mass and suspension within the liquid in the reactor by employing natural mechanical mixing as training. So activated sludge process will comes under this range. The organic matter is converted into the gases in cell tissues. In the most of the process, a high solid concentration is maintained by returning bacteria from the secondary clarifier. This is the activated sludge process they are talking. So a high solid concentration is maintained by returning the bacteria from the secondary clarifier. So there is a primary clarifier, then aeration tank, then secondary clarifier. Water will be flowing from the primary clarifier to the aeration tank, where the sufficient amount of aeration is followed. Aeration is dissolved. After that, water will send for the secondary clarifier, where the biological treatment will be taking place. And there, the bacteria should be always in suspension form. Some of the bacteria will return to the written activated sludge. We will talk about the activated sludge process, then you will understand. Here I have explained, I think, activated sludge process based on this. So here, like water will come from the primary clarifier to the aeration tank, where the diffusers, aerators will be working. Diffused aerators will be there. So sufficient amount of oxygen will be dissolved here. So rich oxygen water will go to the secondary sedimentation tank. Here the bacterial growth will happen, and bacteria will start consuming the organic matter, all the nutrients present in the wastewater, and then biological stabilization will be taking place. Then return activated sludge, the activated form sludge, where the bacteria are in the suspension form, will go again to the here to this sludge thickener, the sludge treatment process, the sludge uh, treatment tank, and there again the treatment of sludge will be taking place. Further addition will be taking place, and then finally stabilized sludge. You will go for the sludge stabilizer. There are the three zones here: septic zones, anaerobic zones. Anaerobic zones. There are the three zones here. Above one will be the aerobic zones. Then will be the partially oxygen will be supplied in that, the middle zone, and then third one will be the completely anaerobic zone. In three stages, in three zones, the stabilization of sludge will be taking place here. And then finally, if biochemical process will be finished, then of course the byproduct will be in the form of methane, 65% to 75% methane, then 10 to 15% CO2, and another fractions of the inert gases like H2S and H2S and N2 will be generated. And finally, the CH4 gas can be collected into the gas holder, and it can be used for the cooking operations or maybe for generating the electricity. If you want to generate the electricity, the biogenerators are attached, and you have to again further you have to separate the. You want a clear methane gas for generating the electricity, so you have to separate the CO2 component and H2S and N2 component from this composition of the gases, because and that you can do it by using the wet filters, scrubbers, and mechanical filters you can attach with that, and you can separate the clear methane. And clear methane is a good source of energy. It's a flammable gas, very good calorific value. You will get it 6,500 to 7,500 kilocalorie per kg. You will get it in there. So it's a good source of energy. You can generate the electricity by using a biogenerator system, or else for the cooking purpose also. Further, you can take this stabilized sludge for the sludge thickening process and sludge drying operations. There's an open tank here. You will put it this sludge in an open atmosphere in sunlight and all that, and it will be finally dried off. You can grind it, and you can make it in a powdered form, and you can use it for as a natural fertilizer. Where we were. So these are the process for the suspended growth process, suspended culture growth process. One is the combination. This is also mostly preferred sometimes. So combined process consists both surface growth process as well as the suspended growth process. So combination sequence is important here. One is trickling filter combined with activated sludge. So first trickling filter unit you have to provide, then activated sludge you have to provide it. Sometimes activated sludge first, then trickling filter second. So like this, and sometimes the facultative levels, where the aerobic and anaerobic bacteria both can survive. Both the condition bacteria can survive. The effluent from the secondary biological plants will usually contains a little BOD, and then you have to provide the various degree of treatments. Degree of treatment will be decided based on the biological, chemical, and physical characteristics of wastewater first that you have to test it. So degree of treatment, generally the pre-treatment, the preliminary treatment is called as 0 degree treatment. Then primary called as a first degree treatment, and secondary treatment is called as a second degree or 2 degree treatment. Like this, degree of treatment has to be decided. Okay, and then if you are going for the tertiary and advanced treatment method, then 3 degree treatment you have to provide. So like this. So these are this is called as degree of treatment. What are the objective? Objective is clear. We have to remove the suspended solid and floatable materials, treatable or biodegradable organic matter, elimination of pathogenic organics, bacteria and microbes from the water that is required, and removal of nitrogen, phosphorus and toxic organic components. For that only, we are going to provide a degree treatment. Now, what are the conventional treatment methods? We have a primary treatment, primary treatment process, and secondary biological treatment process. This is the conventional treatment methods that we have studied about the just now we have in a conventional sewage treatment plant. Some of the advanced wastewater treatment process and tertiary treatment methods, which is required, especially if the industrial wastewater is included in that. If the wastewater characteristics are coming with the very high organic values, like TOC is very high, BOD is very high, and if the industrial wastewater is also included in that, then tertiary treatment is incorporated if it is required. Okay, if it is a normal domestic sewage, tertiary treatment is not advisable. So the chemical clarifier, recarbonation, filtration, if the hardness is very high, then recarbonation is required. Filtration, microfiltration, nanofiltration, right? Activated carbon adsorption, disinfection process like UV and ozonation if it is required. Nitrogen removal techniques, phosphorus removal techniques, and demineralization, all those things comes under the advanced wastewater treatment processes, like a demineralization tank required for the water is having a highly alkaline nature, right? Start from the preliminary treatment. Yeah. Preliminary treatment, as I told you, we have a screening, grid chambers, commutators, as well as the floating units in a skimming tank. Every unit is having their sequence as well as the objective. So screenings are required for removing floating and debris. Grid chambers is required for removing grid sands and clay and soil. And then commutators are required for grinding and chopping materials, large suspended solids. All of the visible particles will be removed from the preliminary treatment. And the skimming tank is required for removing oily and greasy components and fatty acids from the water, because most of the water will come from the kitchen. Of course, the fatty acids and liquids and oil component will coming from there. And from the oil garages, automobile garages, water will be having a lot of thicky and oily and greasy component. From the dairy producing industries, dairy product industries, there are also a lot of oil and greasy components will come out. And from the soap also a lot of oil and grease.
Sir?
Yes?
Sir, can we stop here, sir? We have project review at 6, sir.
At 6, no?
At 6 p.m. exactly. Yes, sir.
6 o'clock, I will... you can leave the class, okay? No problem. Nitesh is also having
Okay.
this. You can leave the class because I have to...
We both are the same group, sir.
Both are in the same group.
Yes, sir.
Yes, sir.
Okay. Next class I have to take 1 hour class is required for it. Yeah, you can leave the class.
Tomorrow you take, sir, again.
Tomorrow I'll take the classes. Tomorrow 1 hour.
Yes, sir.
Tomorrow what time?
So take from 3 to 4 only, sir.
Tomorrow people are free on 3 to 4.
You take it from 3 to 4, sir. We have class till 12:30.
Hmm.
So tomorrow you finish off it, sir.
Yeah, all right. You can leave the class.
Thank you, sir.
Thank you, sir.
It's the preliminary treatment process. So These are every unit is having the following advantages. The frotting units, skimming removal of solids in grease, right? We'll start from the racks and the skin part, physical unit operations. First is the first one, where the water, sewage water is coming from the outfall sewer, and then you are starting from the lateral to branch sewers to the trunk sewer and then outfall sewers, which are interconnected connections for the sewer network. So once the water is coming from the outfall sewer to the directly to the screens for the respective sewage treatment plant, water has to pass through the screens of the various racks in the screen. These are physical unit operations. So uniform size opening, parallel bars generally, rods and gratings or wire mesh or perforated plates we have to provide for it. Generally the size of the circular and rectangular shape. Usually procedure is to pass the influent water through racks or course screens. Bar screens are used to protect pumps, pipelines and valves and other appurtenances from the damages and clogging by racks and large objectives. A bar racks having clear openings greater than 40 mm should mechanically clean with removable facilities. So the bar runs vertically or at a slope of varying from 30 degree to 80 degree with horizontal, and hand cleaned or mechanically cleaned racks. Cleaning devices are racks which periodically sweeps the entire skins in removing solids for further disposal. The types of the skins are, we have a coarse skins, fine skins, as well as the medium skins. The sizes, coarse skin size should be greater than 50 mm, fine skin size should be 6 mm to 40 mm, and then medium skin size should be 3 mm to 6 mm. So these are the skins. They have inclined adherence EV treatment plan with the inclination angle 30 degree to 80 degree in between. So most of the cases 45-degree inclination. This is the mechanical cleaning is happening here. This is an AC induction motor connected mechanical devices which will keep rotating up and down, and it keeps sweep away all the impurities which will locked in these openings, bar openings. So see here all the all the debris, leaves, plastics, containers, left aluminum containers, and everything will be locked here. There's a uniform size distribution. The gradient size, first you have to place the coarse skin, then you have to place the fine skins. Larger particles will be locked here, and it will be removed by the mechanical cleaning devices, and it will be sent to the respective dumping yard. By there is the like solid waste management treatment also for it, for compaction and volume reduction techniques, right? And there are the uh, solid waste management collection part where they will manage everything, reduce the volume, they will thicken the volume, or they cut in the chips, grinding operations, cutting operation, they will do it. And finally, they will take this waste for the landfill or maybe for the solid waste management agreement. Okay. What is the we'll study about the design of the schemes. There are two types of velocities you have to consider. What is the settling velocity? Yeah, design flow velocity. The velocity of wastewater which will be there while the water is entering in these openings. That is called as settling velocity or flow velocity. And the velocity, the velocity of flow of water which will be above from those streams on the top. This is called as the approach velocity. While the water is approaching this speeds, while water is entering through the speeds, the two types of velocity will be considered: approaching velocity as well as the design flow velocity, settling velocity. So the standard design parameters, we have to take a VA as 0.6 to 1.2 meter per second. Cross section area of the skins, you have to take B into H, that is Q in divided by VA. So VA is the width, the depth of the flow, and H is the height of the skin, and the Q in is the flow rate in meter cube per second divided by the approach velocity. You will get the cross section area of the skins. So depth of the flow, you can get it if H is assumed and B is obtained. One is given, suppose H is given here in the questions. So B you can get it by using this equation. Q in will be similar, like there will be the flow rate given in MLD. You can convert in meter cube per second. 5 MLD plant, 6 MLD water is treated through the skins like this. So let S be the size of the opening and be the number of openings. Suppose this is the size of the openings will be S, and the number of openings you can take it as a grid. Now how much bars you are going to take it, you can take it as n. So the number of bars you have to provide one extra, n plus 1, and diameter of the bars you have to take in mm, these rods that you are going to take it. So depth of flow you can get it as by using the formula is equal to n into s plus n plus 1 into this diameter of the bar. Okay, so n is the number of bars, s is the size of openings, like the thing. Like this, the value of psi you will get it. The value of psi generally you can take as 10 mm. We have to take it, and s is equal to 25 mm normally. So head, this is the things in the sequence you can design the scales. Now the head loss is also very important through the scales. The equation of head loss is Vs square minus Va square divided by 2z multiplied with 1 upon 0.7. Vs is the settling velocity, Va is the approaching velocity. So Vs you will get it through this equation, Q divided by net area, and then Q divided by net area you will get it because spins are 45-degree aligned, 60-degree, 45-degree aligned. So uniform triangle, 90-degree triangle, H sin theta. So suppose this is H, this is sin theta you can calculate it. So this value you will get it. This H divided by sin theta you will get it. The inclination of this scale. So the net area you will get it here. So here, yeah, Vs is equal to Q divided by net area, Q divided by n into S into H by sin theta. H means the velocity head of the flow approaching leg. M is equal to V square by 2c. Angle of inclination of leg with the horizontal, that is, as I told you, theta. Vs is the velocity through the skin in meter per second. Through the skins. In velocity, approach velocity, velocity before the skins in the meter per second. There are some devices that is required to slow down or make the constant velocity, like partial flume and weighers and all that you have to provide it, so that the velocity can become constant on the screens. We don't want the turbulent flow and the variation in the screens. So the uniformly, because we need some retention time also while the impurities are lurking in the bars. The velocity of 0.6 to 1.6 meter per second throughout the open area for the peak flow has been considered satisfactorily. Further, the velocity at low flows in the approaching channel should not be less than 0.3 meter per second to avoid the deposition of the solids. So this is the head loss equation. Same equation, see you can put it as 0.7. It again depends. If it is a clean bars, then you have to take 0.7. If it is a clogged, then 0.6 you have to take it. The empirical discharge coefficient to account for turbulent and eddy losses is the velocity of the through opening bag to meter per second. These are some numericals on the screens. Find the number of bars. Diameter of the bar is given, each diameter. Discharge flow rate is given 25 LD. Size of opening is 25 mm. Approaching velocity 1 meter per second. If it is not given, you have to consider 0.6 meter per second to 1.2 meter per second in that range. Head is given 0.9 meter. Find head loss if the angle of inclination is given 60 degree. Theta is given 60 degree. So simple, apply the formulas. First, you convert the MLD into meter per second. So 25 into 10 to the power 6 million to liter. Then liter to meter cube. Conversion divided by 10 to the 3. And that is 24 into 60 into 60. We have written as 86400. And then finally, you will get this flow rate as 0.289 meter cube per second. Now, width into height, depth of flow into height will give the Q divided by VA, that standard equation that we have derived here, imported here. Same way, Q divided by VA. So Q is 0.289 divided by 1 you have taken as, then meter cube, you will get it as a Now H is also given here 0.9 meter. So you put it as H, then you will get this value of bit depth of flow is 0.3215 meter. Okay, width you will get. Now what is the formula for width? The depth of flow is equal to n into S plus n plus 1 into diameter. Then you can put this S you already know, n you have to determine it, V you already know, n is unknown, then you will get the number of bars. So if we solve it, the unit conversion you have to take here. Width is given here as 0.3215 meter. So 0.3215 meter multiplied with 10 to the 3 meter to mm conversion.
n into 25 because 25 is given mm, so you put it in 25 as it is. N plus 1, 10 is also given mm and mm. So uniform unit in right side and left hand side. So like this you will get roughly n is equal to 8.9, approximate n is equal to n because it's a number of bars, so you have to take exact number. And the number of bars will be n plus 1. You have to take one extra for adding and standby board. N plus 1 is equal to 10. Then Vs is equal to Q net divided by net area, that you know that. And that you can convert by using this formula. This one, Q net, Q divided by N into S into H by sin theta. Theta is 6 degree. So like this you will get it 1.237 meter per second. If head loss you want to consider, then Vs square minus V square divided by 2Z into 1 upon 0.7. Then you put all the parameters, you will get all the values. Like this simple numericals will be here. The next is grid chamber. The water which will come from the skins will send to the grid chamber. The grid chamber is aimed to remove grit from the wastewater flow. If grit is not removed, it increases wear and tear of the pumps and pumps used at a treatment plant. Grit also settle down fast and occupy space left for longer. The grit chambers are used for the following purpose. Number first, to remove the inorganic grits. The inorganic size grit should be less than 0.2 mm. Specific gravity should be greater than or equal to 2.65. Sand, silt, clay, cinder, broken glass pieces, metal fragment can be removed. These are all coming in organic fragment. Then the organic substances like non-biodegradable grits size should be greater than 2 mm. Specific gravity should be 1.05 to 1.1. The coffee grounds, tea eggshells, bone chips, and grains, seeds, etc. will be coming in the organic substances. So both of the types of substances, grit particles can be removed. So grit chamber generally is a narrow, long rectangular channels with increased cross-sectional dimensions. They accelerate the flow velocity and allow grit to settle down. You have to provide retention period for it. So generally to 0.45 seconds to 90 minutes, 90 seconds you can provide a retention time for it. So 1 to 3 minutes maximum. The grid chamber is a settling tank with the provision to control flow velocity. A velocity control device known as a proportional flow weir is provided to the outlet of the grid chamber to maintain the constant flow velocity irrespective of the flow rate. So as I told you, while the water is coming from the skins, of course the flow will be higher. The flow velocity will be higher. So you have to reduce the flow velocity because you need a laminar flow. Slow down the velocity, constant flow rate you want. That's why you are using a flow weirs and all that. A partial film chamber you need to provide to slow down the velocity. The 20% increase in the flow velocity leads to scoring of the settling bit. Similarly, 25% decrease in flow velocity leads to settling of other particles. A flow velocity of 0.3 meter per second is provided, which neither allows scoring nor settling of other than grades. So flow velocity generally you have to consider for the horizontal flow 0.3 meter per second. Range you have to consider 0.25 meter per second to 0.4 meter per second. Retention time generally 1 to 3 minutes. Sorry. The volume of grid chamber, how you will get it? Q multiplied with retention time. So here we are. Retention time should be provided 1 to 3 minutes for the grid chamber. Volume of grid chamber. These are all the design constraints for the grid chamber. How to do that? The flow rate multiplied with retention time will give the volume. The cross-sectional area, there are two areas here. One is the cross-sectional area, another one is the surface area. The surface area will be means length into width, L into B. If it's a rectangle channel. If I'm talking about the cross-sectional area, then width into height. Okay. So suppose surface loading rate, if you want to find out, then you have to divide Q divided by surface area, that is L into B. Okay, so that you have to take care. If you are going for this thing, cross section area B into H, you have to find out flow rate divided by the horizontal flow velocity. You will get it. Anything is missing, you can get it. The length of the grid chamber, we have to take like this. L is equal to length of the grid chamber will be equal to horizontal flow velocity multiplied with the detention time. So anything is missing, you can get it. Now the settling velocity for the grid chamber exclusively these, so it's a kind of it's a discrete particles storm equation. So the same thing. So the settling velocity for the discrete particles, yeah, the grid chamber will be z into s minus 1 into d square to the divided by 18 into nu. Nu is the kinematic viscosity of particles, and then S is the specific gravity ratio of two mass densities, rho S divided by rho water. Z is the gravity constant. So settling velocity, you will get it here. Most of these is centimeter per second. S is dimensionless, and then nu, that is called as what we call as kinematic viscosity. It will be in centimeter square per second. So the unit conversion should be clear here. The control velocity of flow through the grid chamber, as I told you, proportional flow where you have to attach centrovias, partial fume, Pullman, Bowles fumes also sometimes used. So the grid particles lies in between 0.1 mm to 1 mm size. The zone of settling corresponding to this range of particles is called the transition zone. The relationship between the settling velocity, size, density of particles, density and temperature of the liquid is given by the Hessian modified equation. If temperature is also incorporated, then Vs should be 60.6 into S minus 1 into D into 3T plus 70 divided by 100. All usual notations, T in the temperature in degrees Celsius, S is the specific gravity, rho S divided by rho W. Vs is the settling velocity, you should get in centimeter per second. And then length should be, standard length should be 7.5 to 20 meter. Width should be 2.5 to 7 meters, and depth should be 2 meter to 5 meter. So these are the conditions for the settling velocity for the grid chamber. If temperature is given this equation, you have to use it exclusively. Temperature is not given. So this is top equation. Same thing we have studied in discrete particle settling. Settling particle 1 and 2 and third settling 1, settling 2, settling 3. Type 1, type 2, type 3. So discrete settling and ring settling like this. Same thing we will be studying here. Okay. There's the overflow rate. As I told you, Q divided by surface area. Flow rate divided by surface area will be the overflow rate. Unit will be meter cube per day per meter square. If the grid having specific gravity 2.65, most of the cases in organic substances you get 2.65. The Vs value you will get it D into 3T plus 70. Then this equation we are solving it. If S is defined there, S is 2.65. If you solve it 2.65, you put it, you will get this value. For the organic grid, S you generally you take a 1.20. Then if you put a 1.20 in terms of S, then you will get this equation. Detention time varies 45 seconds to 90 seconds, as I told you. You can take 1 minute to 3 minutes maximum. Detention time of 60 seconds is usually adopted. Settling grid is safe and disposed of by any methods. There's the bottom scouring, that is also very important. The bottom that sludge is deposited, the part, the grid portion is deposited, it has to be taken out from the grid chamber. We need a grid chamber clean for the further fresh operation. Okay. So the flow velocity should be enough to scour out the settling organic matter and reintroduce into the flow stream. So VC is the critical flow velocity for the scouring. The modified seal formula is used for this. The VC should be 3 to 4.5 into Z into SS minus 1 into D to the power 1 by 2, under root of all those things. Okay. 3 to 4.5 under root of Z into S minus 1 into D. That's all. So the scoring velocity you will get. For grid particles 0.2 mm, the critical score velocity should be 17.1 to 25.6 centimeter per second. For the horizontal flow velocity, VH should be 15 to 30 centimeter per second is used at peak flow. That's the condition. There's a question given here. Simple questions will be given. Suppose length is given, width is given, and height is given, and the flow rate is also given 720 meter cube per hour. Surface loading rate we have to determine. So what is the surface loading rate? Flow rate divided by the surface area. What is the surface area? Length into width here, not h into b, b into h. That is the cross section area. Okay, you must understand the difference between surface area as well as cross section area. So 720 divided by 12 into 1.5, you will get it in 40 meter cube per hour per meter square as surface loading rate. Now you convert into the liter, then 40,000 liter per hour per meter square. Detention time as the same in sedimentation tank, you get the detention time value to V divided by Q, volume divided by flow rate. Same way you will have to do here also. Volume will be length into width into height divided by Q is the flow rate, that is 720. You will get as 1.2 minutes. Now VH, the horizontal flow velocity, as I told you, you have to take a standard, so you take a 0.3 meter per second. For the grid chamber, the cross-sectional area is equal to Q divided by VH, that is standard equation. So cross-sectional area means B into H is equal to Q divided by VH. And VH you have taken 0.3, 3 is already given, then you will get a 10 meters square, one particular question. So B and H, anything you can take it. Suppose one particular question S is given 2.7, diameter of the bar is diameter is given as 0.2 mm for the particle diameters, this is the particle diameter, and the specific, not specific, the kinematic viscosity of particles are given as 10 to the minus 2 centimeters square per second. So Vs, the settling equation, stock equation, you can use it. You will get it as what is the answer? 4.08 centimeter per second. Always you will get a settling velocity centimeter per second. It is not, you have to convert it. The range should be 2.6 to 5 centimeter per second. After the chamber, water has to send for the skimming tank for removing oil and DC component, as I told you. The skimming tank operations are like this. I'll come later. It is aimed to remove the oily and greasy granular component from the wastewater. Oil remaining affect secondary treatment and also cause problem to the disposal system. That's why it has to be removed. Specific gravity of oil and grease is less than the specific gravity of wastewater. Therefore, they cannot settle oil and grease removed by the flotation. The flotation is carried out by applying compressed air from bottom so that oil and grease rise and float to top of the skimming tank. From there, oil and grease is skimmed off. Now, design of sedimentation, the design of skimming tank, we need to find out the surface area of the skimming tank, that is length into width. The formula is there, 0.00622 Q divided by VR. These are all empirical formulas, not direct. Okay, directly from the design parameters, we have to check it. So 0.00622 Q divided by VR. VR is the liquid rise velocity. Standard value you have to take 0.25 meter per minute. And then overflow rate. Overflow rate will be meter cube per day. Not overflow rate, flow rate only. Actually, how much capacity of water you are going to treat it. I will send it in a skimming tank. So flow rate will be decided already. 5 MLD, 2 MLD, 3 MLD, whatever. So it will be meter cube per day. If you have to convert, it is not here, you have to convert it meter cube per second. Detention time you have to provide for a 3 to 5 minutes for these operations. So skimming tanks are installed just ahead of the sedimentation tank, a primary clarifier, to remove the floating substances like grease, oil, fatty acids, and vexes, soap, free fatty acids, fluid stains, and piece of cocks and wood, vegetable debris, etc. Source of pollutant for this: oil and grease substances enters in the seaways from the kitchen of the restaurants and houses, motor garages, oil refineries, soap and candle factories, etc. The skimming tank is a chamber so arranged that floating matters rises up and remains on the surface of the wastewater until removed, while the liquid flows out continuously. आता हुआ तो कुछ देर में खत्म करना लेक्चर. So The skimming tank is a chamber wherein the floating matter rises, remaining on the surfaces of the wastewater until removed, while the liquid flows out continuously through a outlet chamber located at the depth or under partitions. Curtains walls are provided. Deep spun board is also there. 3 to 5 minute detention time is required for it. Trough shape skimming tank. There's the various types of shape of the skimming tanks. Generally, trough shape or rectangle shape is required. Divided into the three of two lateral compartment by vertical buffets having a slot for short distance below the wastewater surface, permitting oil and grease component to escape into stilling compartment. Air diffusers are provided at the bottom of the tank. Rising air buffers yields the greasy and oil materials and push it to the side compartment. The amount of air is required for diffusing actions. So air will be compressed from there will blowers used. Compressed air is used by using compressors and blowers, and it will be blown from the bottom of the tank, and not the bottom of the tank. From the bottom side, air has to be blown. So the floating particles and oil and greasy components can come on the top and will be in the flock form and can be separated out by using skimmers. The amount of air is required 0.2 meter cube per meter cube of seaways. That amount of air is required. The floating material can be removed either manually or skip through the skimmers. Mechanical arrangement is there. Volume of skimming tank varies from 0.625 to 37.5 meter cube per million cubic meter of seaways. The vacuum flotation and chlorine may also be added. For if you want to increase the efficiency of skimming, then chlorine works. Chlorine works as a good component, so you can increase the efficiency of skimming. Also, the doses of 1.5 to 2 mg per liter is sufficient for the efficiency improvement of the skimming tank. Okay. Also, the vacuum flotation is also very good technique. Through this, you can increase the efficiency of the skimming tank, the removal efficiency. You see there, this is the skimming tank. This is the clear water down. This is the emulsion and oil portion on the top. Because specific gravity, there's a difference between the specific gravity of oil and water. Because the gravity is lesser than fresh water. Yeah. So this is a series water which is coming out from the git chamber, and it is having a lot of oil and DC components. This mechanical arrangement is operated by pneumatic valve operation, where the pneumatic forces, pneumatic pressure is applied. It is movable in to and fro directions. There is a cylinder piston mechanism. Pneumatic pressure is generated. It will be what is happening. This is the skimmer, rectangle skimmer. It will take away all the impurities with it, and it will send to the tank where it will be stored. And then fresh water will be going out by using the underwater drainage system. Okay, so these are the skimmer moving into and fro direction, plotting roof. This is the probe stopper actually, it will come till there. And then high probes is required. So the mechanical arrangement they have put it. And then if it is a like vegetable piles and vegetable and other wooden pieces, wooden scraps, so it can be removed by using this floater, this skimmer. So it will catch everything. Okay, so it like this somehow the way oily and greasy component. So this is the inlet. This is the cross sectional view here, top view and front view. This is the side view. So water is coming and water is going out. Skimmers are working. Water is skimming oil to sun. Next is the primary clarifier. Primary clarifier, next unit after skimming tank, water is to send either an equalization tank or generally directly for the primary sedimentation tank, a primary clarifier. So we have various type of sedimentation tank, horizontal flow, vertical flow type. circular type, rectangular type. In the my previous series lectures, I have gone through in detail about the sedimentation tank design and the process of coagulation and flocculation, means sedimentation as well as the sedimentation followed by coagulation. This sedimentation tank complete design we have gone through in detail. We have done some numerical on that. So I'm not going in detail in primary sedimentation tank. You must know there are the type of settlings here, type 1, type 2, type 3, type 4, and type 5, type 4. So type of hindering settling will be used here. Sedimentation followed with coagulation. So the tank design, this is a circular types of design, circular tank design, sedimentation tank. These are the scrapers here, mechanical scrapers magnets that keeps rotating. Because the buffet attached here to convert the turbulent flow into the laminar flow. This is the partial flume or flash mixing chamber for mixing the coagulant. And what is entered here, and there is a coagulation and flocculation process will be taking place because alum generally and ferrous sulfate we are adding as a coagulant. So coagulant is a chemical coagulant. It helps to grow all the impurities inside, because most of the impurities are in finely suspended solids, so we cannot, it will be in suspension form. So we have to increase its size and grow. There's a chemical precipitation and physical sedimentation will be taking place. All the impurities are negatively charged, and elements doses are also, we have to define it. So the chemical reaction will be taking place in finely neutralized solutions. The lighter impurities will come up on the top, it will generate on the top, flock will generate on the top, and heavier substances, impurities will go down because of physical sedimentation, gravity settlement, and it will go down. And these physical sedimentation impurities can be settled down into the sludge tank. And then you have to clean this chamber because it's a circular chamber. These walls, the impurities will stick with the walls. So for cleaning that, we have to use the scrapers. And for the floating material also, the flock will be on the top now. For removing this, it is that the scrapers, mechanical scrapers are used. It is operated with the induction motor. It keeps rotating. It comes up and down also. And then there are the rubber pads attached with it. So it will scrape out all the impurities from it. There's inflate, scum trough. There's a various design parameters, design components attached with this. Okay. The primary clarifier is assumed to capture settleable organic solids present in a wastewater. 70 to 80% of biodegradable organic solids are captured, contribute 30% of BOD removal. Primary clarifier follows type third of settling, like hindering settling. Design surface overloading, you have to take 30 to 40 meter cube per day per meter square. Detention time 1.2 hours. The surface loading rate, you have to take Q divided by EF, same formula. Detention time, same formula. P divided by Q, horizontal discharge velocity. You can take Q divided by cross section area. Cross section area will be into H, surface area will be L into B. So like this, you have to design it. This is the primary sedimentation tank. So in detail, I have explained about all types of settlings and what kind of coagulation flocculation processes are happening. What is discrete particle settling, right? All those things we have explained. So the flow through period also play an important role here. It is the average time required for a batch of wastewater to pass through the settling tank. Displacement efficiency is the ratio of flow through time to the detention time, TD2 divided by dt. There's the plain sedimentation with coagulation, and chemical precipitation. The three processes are happening here. Plain sedimentation, if you are not adding coagulant, then sedimentation followed with coagulation, and then third one is the chemical precipitation, and the fourth one is the physical sedimentation. So there's the types of settling. Type 1 settling called sedimentation, yeah, discrete settling. Discrete particle does not settle down, and that is always there's not a change in size and shape. And type of second settling is called as flocculent settling. Type of third settling is called as hindering or joint settling. Type fourth is a sedimentation or compression settling. So the various cross-sectional view of sedimentation tank. Primary sedimentation tank is the scraper, molding. How the processes are taking place is explained in detail. Hello? These are all those things. We'll talk later once we have a time in regular classes, everything. Cross section of clarifier, all the components. Now we move for the secondary treatment process. These are the physicochemical process, and then the mechanism of food growth versus time graph, how the biological processes are taking place, right? And how the process will be taking place. All those things. That we'll talk later in once we have a time for it. Then activated sludge process, how the process will be taking place, activated sludge process, what are the ratios, what are the numerical portions that we have to cover, design parameter for activated sludge process. Then there is a modification activated sludge process, and then we have sewage filtration like trickling filters, right? So that's okay. Thank you for the today's class, and we have a nice time with you. And yeah, we try to explain the maximum part. And thanks for the CMRIT for giving me the opportunity delivering the lecture and preparing our lecture. This is the time was very hectic. We are very busy with the academics, and we spare our time for the preparation, and it was consume a lot of time for preparation, preparing the materials, PPTs and slides, delivering our 2 hour lectures continuously. So from the regular studies from the academics, sparing a time for the GIT class is difficult, but still I tried my best. Thanks for the CMRIT management, principal sir especially, and Pani Kumar sir, who has given me opportunity for taking the GIT classes. So I hope it helps a little bit in your competitive exam point of view. We have a time, we will take another class also. Yeah, for my parts, we'll bind up the session. Thank you so much once again.